be looking at today is hyperbolas, right? So we're going to use what we already know about conics, right? Because this is the fourth conic we've learned. Wow. Right? We know circles, we know ellipses, and we know parabolas. We don't know how to spell it, but we know it. But we're going to specifically use what we know about ellipses, that will come in a lot, to define and analyze hyperbolas in a variety of forms. The same idea where, like, maybe I'm going to give you some information, maybe I'm going to give you a graph, maybe I'm going to give you an equation, maybe I'll give you an equation you'll have to do, I don't know, completing the square to get it in graphing form. So tying in like what we've learned with each conic to work with hyperbolas as well. So here's an ellipse. My question for you is, how do we know this is an ellipse? Well, there's an x squared and a y squared term. Those are a and c. A doesn't equal to c, and they don't equal to 0. And they're the same sign. Therefore, it's an ellipse. Right? If I wanted to get this in graphing form, I would divide everything by 144. Right? And I would end up ultimately getting this, right? Maybe you're writing it as x squared over 16 plus y squared over 9. That's fine, right? That's the same thing. That's just the squared being distributed. So this would have a center of 0, 0, right? This would have, to get to the vertices, you'd be going right 4 and left 4. So you would have vertices at 4, 0 and negative 4, 0. You're looking at which one's larger to figure that piece of it out. The co-vertices would be 0, 3 and 0, negative 3. To find the foci, you would do c squared equals a squared minus b squared, right? And those would be on the major axis. So when we graphed this, this would look something like this. If I do something as simple as changing the sign to a negative, I now have a hyperbola. So how does that impact the graph? Well, we're going to cut this graph right along the minor axis. And it's going to turn out. I'm going to go into more description of what really happened there. Notice my vertices stayed the same. This is still a vertex at negative 4, 0 and 4, 0. My center stayed the same, 0, 0. My, what are these called? Foci did not stay the same. I now am going to have a focus, an equation that is a squared plus b squared, right? Okay. A is still going to be the distance from the center to the focus. I'm sorry, the center to the vertex. B is going to be the distance from the center to the, I'm going to very loosely use the word co-vertex because it's not really a co-vertex. But there is going to be some different words. Like this axis, what you knew as the major axis, is actually going to be called the transverse axis. Remember when we always said A was greater than B? That's not necessarily true here. Sometimes it might be, but it's not required. So A is determined by which term is positive, right? Because they're not both positive. The other thing a hyperbola has is it has these lines, asymptotes, slant asymptotes, right? You guys did some work with asymptotes, especially with like rational functions and logs and exponents. Asymptotes are lines the graph approaches but never touches. Oh man. So these are slant asymptotes. They're lines. We're going to write the equation of them, but they're not going to be quite as simple as y equals 3 idea, right? Because they're really clearly at an angle. There's a slope other than 0 or undefined. And they're going to guide what the hyperbola looks like on its ends. Okay? So as I kind of just said, this axis is called the conjugate axis. This axis is called the transverse axis. I might have just mixed that up. So the one where the vertices are not, the one that's kind of connecting the co-vertices is the conjugate axis. The one that's connecting the vertices is the transverse axis. This operates just like the major axis. It's a different name. This operates just like the minor axis. Okay? This might be in your way. Oh. Okay, I'm going to summarize this. And this is a lot to take in. Maybe you remember some of it, but it's a lot to take in. So hyperbola. So general form. Ax squared minus cy squared plus dx plus ey plus f equals 0. Or negative x squared, negative ax squared plus cy squared plus dx plus ey plus f. So these two have different signs. There is an x squared and a y squared, but a and c do not have the same sign. One is negative and one is positive. A equals c does not equal 0 was a circle. A does not equal c, and they both aren't equal to 0, but they have the same sign, is an ellipse. Either a or c is 0, right? So there was only one square term. It was a parabola. And if neither a nor c are 0, but a and c have different signs, it's a hyperbola. So that even goes for like you have a 1 and negative 1. Those are different signs. That is going to lead to a hyperbola. So you just got to be mindful and careful with that. So here are two images with some equations going on. So this, when we graph it, is what it's generally going to look like. So this axis is called the transverse axis, as is this one, transverse axis. This axis, the one that connects what we're calling the covertices, is called the conjugate axis. This one is called the conjugate axis. B is like the semi-minor axis idea, and A is still like the semi-major axis. It's not called the major, minor, but that's the idea of it. A doesn't have to be bigger than B, right? So we're going to be creating this box in order to guide the asymptotes, which are going to show us how wide it's opened. And then to find the foci, the focal points, is c squared equals a squared plus b squared. So whichever one is positive, whichever term is positive, tells us where you're going to go to get to the vertices. So it's going to tell you which way it opens. So in this case, my y term was positive, so it's opening up and down. I'm going to go up and down to get to the vertices, and you're going to go up and down A. Right? In this case, your x was positive. So I'm going to go right and left to get to the vertices, and I'm going to go right and left A. So A is going to take us to the vertices. B is going to take us to what I'm going to refer to as the co-vertices. They're not actually points on it, but they help us to construct this. So let's look at this example. Same one we just had. Now we're going to formally graph it. So to start off, divide everything by 144. So I've got x squared over 16 minus y squared over 9 equals 1. So this is going to have a horizontal, transverse axis. So that means it's going to open left and right. I know that because my x is positive. So a squared is going to be 16, so a will be 4. B squared is going to be 9, so B will be 3. Right? The center is at 0, 0. I think I have this graphed. Yeah, the center is at 0, 0. I'm going to go left and right 4. So this is 4, 0, and negative 4, 0. And then I'm going to go up and down 3. So this will be 0, 3, and this will be 0, negative 3. This, the green dotted line, is my transverse axis. This is my conjugate axis. These 2 points are my focus points, and how I find them is by doing c squared equals 16 plus 9. So c squared equals 25. So c is 5. So I'm going to be going right 5 and left 5. So it's along the transverse axis. So like this would be 5, 0. This would be negative 5, 0. I'm going to create that box, maybe, if my computer will let me, by just sliding these over. And then my asymptotes will go through those. Asymptote, asymptote. And there's the hyperbola. Okay, so the last thing we want to do is write the equation of the asymptote. So we have the asymptotes are lines. Asymptote equations. So you know how to write the equation of a line, right? You probably remember y equals mx plus b, right? That's useful if you can see the y-intercept or if you know the y-intercept. So in this case, you know it, right? You also have that equation y minus y1 equals m times x minus x1. This is the one I tend to use because both of these asymptotes share a point, right? That x1, y1, I use the center. I use the center HK for that. The slope, oh, look at this. In this case, it's just going to be b over a, right? It's like the square root of the denominator of y over the square root of the, so in this case, it's going to be b over a. This one would be b over negative a, right? So like it's, the slope is just the positive and negative version of that. Like they're just, it's just a reflection over the y-axis. So the equation of these asymptotes would be y minus 0 equals the slope. Well, in my case, it's rise over run, so b over a, the y over the x. So 3/4, so plus or minus 3/4 x minus 0. So I could probably simplify that a little bit. Y equals plus or minus 3/4 x. And obviously this one is the positive 3/4 x, and this would be y equals negative 3/4 x. Okay. Let's look at another one. So, vertical or horizontal transverse axis? Well, which one is positive? Y is positive. So, it's a vertical transverse axis. Okay, so the center is going to be 2, negative 1. Just be careful there. HK. And since it's a vertical transverse axis, I know a squared is 9. So a is 3. B squared is 25. So b is 5. I'm going to plot my center. 2, negative 1 is the center. To get to the vertices, I'm going to be going up and down 3. Well, that affects y. So negative, oh no. 2, negative 1 plus or minus 3. So my vertices will be 2, 2, and 2, negative 4. Does that make sense? 1, 2, 3, 2, 2, and 2, negative 4. Those are my vertices. So I obviously am not asking you for covertices because they're not really points on this. I'm just going to use it in order to draw that box. So I'm going to be going left and right 5 from the center to get to that box. 1, 2, 3, 4, 5. I'll put a little point. 1, 2, 3, 4, 5. I'll put a little point, and then I'm going to draw that box. And I'm going to make that turn so I can get to that point. It's a rectangle. It's a box. Oh, I'm going to have to make a turn. And then here. So there's the box that I'm going to create. And if I connect the center and these 2 points on the corners, that's one of my asymptotes. And we will momentarily write the equations of it. Same thing here. There's my 2 asymptotes. And then if I'm going to draw, I want to get that purple back, or that magenta back from my vertices, and it approaches. Whoa, that looks interesting. The asymptotes. Just like rational functions. Okay. So to get the focus points, it's c squared equals a squared plus b squared. So remember, c is still a distance. So c squared equals 25 plus 9, or 9 plus 25. Does not matter that order, which is 34. So c is going to be the square root of 34. Right? I think that's going to be somewhere between 5 and 6. So from the center, I'm going to go up 5. 1, 2, 3, 4, 5 and something. So like here's a focus. And 1, 2, 3, 4. Here's a focus. Okay, so this point, and I'm going to write, I guess I could write them over here. That point, I'm going up and down again, so I'm staying at 2, -1 plus or minus the square root of 34. Right, so this would be 2, -1 plus root 34. This would be 2, -1 minus root 34. So it's still like the hyperbola is opening around that focus. The last thing we want is the equation of the asymptote. So I'm going to use the center as my x1, y1. So I'm going to have y plus 1 equals plus or minus, I'll come back to that in a moment, x minus 2. So I'm going from the center to this point, or the center to this point. It doesn't matter. My rise is 1, 2, 3. My run, right? Oh, that 3 came from whatever's under the square root of whatever's under y. The run, 1, 2, 3, 4, 5. Oh, it was the square root of that 25, right? And that's going to be the equation of my asymptotes. This one would be the y plus 1 equals -3/5 x minus 2. And this would be y, I'm referring to this, plus 1 equals +3/5 x minus 2. Awesome. Okay. Let's look at another one. I would say maybe challenge yourself and pause the video and give this one a shot. Is this going to be a vertical or a horizontal transverse axis? Well, which one of these is positive? Oh, the x term is positive. So this is going to have a horizontal transverse axis. The center is going to be 3, -1. Your a squared is 49. So a is 7, and you're going to be going left and right. Right? So I'm going to be going left and right 7. So it's going to be 3 plus or minus 7, -1. So your vertices are -4, -1, and 10, -1. Let's see, -4, 10, -1, and -4, -1. So I do need to figure out b squared is 4, so b is 2, and that's going to help me get that box. I'm going to go up 2, down 2, and then I've got this like long, narrow, oh, that is interesting, long, narrow box. There's change colors. Not sure why I'm telling you guys that. It's okay. So I need my asymptote to go through all of that. Oh God, I need a ruler. It's okay. And then all of this. Let's get a nice, nice color. So there is my hyperbola. And then I just need the foci, right? So c squared equals a squared plus b squared. So 49 plus 4 is 53, which I don't, does that divide by anything? No. No. So c is the square root of 53, which is between what? 7 and 8. So 1, 2, 3, 4, 5, 6, 7, so like right there. And 1, 2, 3, 4, 5, 6, 7. Notice I'm going from the center. Be careful there. So this is going to be, my 2 points will be 3 plus and minus the square root of 53, -1. Right, so this point would be 3 minus root 53, -1. This point would be 3 plus root 53, -1. What about the equation of the asymptotes? So I'm going to use the center again. So it's going to be y plus 1 equals plus or minus something, x minus 3. Well, I'm going to be going up 2, so plus or minus 2 over 1, 2, 3, 4, 5, 6, 7 over 7. And there's the equation of my asymptotes. All right. You guys knew it was coming, right? Oh, it's not in graphing form, right? So obviously we're learning about hyperbolas, so you're probably looking at this and you're like, well, obviously this is hyperbola, but how do we know it, right? Because now that we've learned all four, how can we identify before we even go to try to like use our algebra to get it to that point? So if I focus in on my coefficients of x squared and y squared, they are different signs, right? You have 25 and -4. Different signs, therefore it's a hyperbola. So we know what we want it to look like at the end. So let's do the exact same thing that we would before. 25x squared plus 200x plus -4y squared. Careful, you can't just separate that, right? It's a -4. That's the coefficient. Minus 8y equals -796. So just like what happened before when we dealt with ellipses, these coefficients, this 25 and this -4, are hindering our ability to complete the square. Right? So we know we're going to have to add something in, but we don't exactly know what, and it's hard to do it without factoring it out. So I'm going to divide everything here by 25, even that number I don't know. And you're going to be left with 25. X plus x squared plus, what is that, 8x plus something. I'm going to factor out a -4. Minus 4, y squared, so it's going to divide everything by -4, even this number right here, plus 2y plus something equals whatever that number is, right? So let's see, 25, what are the two numbers that add to 8 that are the same number? Well, 4 and 4, so this is a 16. But we didn't really add a 16, right? The 16 came from some number divided by 25. So factor that back in to figure out what you actually added, 400. So I'm really going to add a 400. Well, what about here? Minus 4, y, those two numbers that add to 2 that are the same, 1 and 1. So this is a 1, but careful, you divided a -4 by that. So this has to be a -4, right? I have to factor that back in. So I'm really, like subtracting 4. So let's see what happens. -796 plus 400 minus 4 is -400. So I'm almost at standard form, but now to actually get it in standard form, it needs to equal to that 1. So I'm going to divide everything by -400. And this is really neat. 25 divided by -400 is -1/16. So you have negative x plus 4 squared over 16. What about -4 divided by -400? Well, that's going to be positive 1/100. This just became the positive one. Y plus 1 squared over 100 equals 1. And there you've got it in graphing form. I'm going to run through the graph of it as well, just for the practice. I'm not sure what color I would like. Great. So this is going to have a vertical transverse axis. How did I know that? I looked at which one was positive. So even though the x is first, this is the positive one. So you have a center at -4, -1. It's a vertical transverse axis, so my a squared is going to be 100. So a is going to be 10. So I'm going to be going up and down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 10, I'm going to be like 1 off right here at -11. Okay, so I need to create that box. So I'm going to look at, well, b squared is 16, so b is 4. Right, so I'm going to go right and left 4 to get that box. 1, 2, 3, 4. 1, 2, 3, 4, and then I can create that box, which just helps me get my asymptotes. All the way down, turn the corner, all the way down. So let's get these asymptotes drawn. Through that corner. There's one. There's the other. There you go. Right, so then here my vertices, it was vertical, right? So here's my vertex. Whoop, whoop. This is gonna be a little bit hard. Whoop, whoop. Oh no, it doesn't even look like it's touching the vertex. I didn't plan well for that. So what am I missing? I'm missing the focus points, right? So c squared equals 100 plus 16. So c equals the square root of 116. Does that simplify? Yeah, 2 root 29. Man, this is like really not working for me right now. So to get to the focus points, I'm going to be going up and down root 29 to root 29. So it would be -4, -1, plus or minus 2 root 29. Right, so 2 root 29 is about what? It's like between 10 and 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like right here. And that would be down 10, so like right here would be my focus points. The last one, I guess I probably want the equation of my asymptotes. So that would be y, use the center, plus 1 equals plus and minus. To get from the center to this point, I'm going up something. I'm going up 10 over 4. 10 over 4, so that's 5 halves. X, what is this? Minus x plus 4? Yeah. Would be the equation of your asymptotes. It was a loaded problem, right? So that the new piece of that from the other slides was coming up with the standard form. I'm sorry, the graphing form from the expanded form. Let's do another completing the square. Maybe try it on your own if you haven't given one a shot yet. You got this, guys. So again, I know that it's an ellipse, I'm sorry, a hyperbola, because A and C are different signs. So I'm going to do some grouping. I like didn't load. So let's see. Those numbers are going to stop me, so I'm going to have to do some factoring. Right, so I'm going to divide everything by -4 here. Even that number I don't know. Then we have a -4, x squared plus 4x plus something. And here, I'm going to have to divide everything by 9. even that number I don't know, plus 9, y squared minus 12, y plus something equals negative 344 plus something plus something. So negative 4, this would be x plus 2, because 2 and 2 is 4. So this would be a 4. But you had already divided this number. Like to get this, we divided by negative 4. So you've got to factor that back in. So really, it's a negative 16. So I'm really subtracting 16. For this one, plus 9, y minus 6, right? Negative 6 and negative 6 is 12. So this is a 36. But you already divided that 36 by 9, so you got to factor that back in, and it's really a 324. So this is a negative 16, and this is a 324. So you've got, oh, I forgot, I need to write this here. So negative 344 plus, nope, minus 16 plus 324. I got negative 36. So I've almost got it. My last step is just going to be to divide by that negative 36. Negative 4 divided by negative 36 is positive 1 over 9. Nope, not a plus, right? 9 divided by negative 36, that's now going to be a minus. Y minus 6 squared divided by 4. 9 over 36 is 1/4 equals 1. So this would be horizontal. It would have a horizontal transverse axis. The center is going to be negative 2, 6. Horizontal, so a squared is 9, meaning a is 3. So I should go right 3, 1, 2, 3, and left 3 to get to my vertices, 1, 2, 3. And then to make that box, what color should we do that in? We never use yellow. What does it look like? I need to go up 2 and down 2. Maybe not my best color choice, but it's okay. It's okay for the box. This one's little. So I need my asymptotes. An asymptote. And then I know that this is going to look like this. And then I need to find my focus points and the equation of my asymptotes. So the focus, c squared equals a squared plus b squared, so 9 and 4. So c squared equals 13. So c is the square root of 13. Right? So I'm going to have to go right and left from the center. So negative 2 plus and minus root 13. 6 would be your focus points. So root 13 is going to be what? Somewhere between 3 and 4. So I'm going to go 1, 2, 3, and a little bit. 1, 2, 3, and a little bit. To get to my 2 focus points. My last thing is the equation of the asymptotes. So y, use the center, minus 6 equals plus or minus up 2 over 1, 2, 3. So 2/3. So I'm getting that by just looking at this change over this change, the rise over the run. X plus 2 would be the equation of my asymptotes. Right, so that would give us this as well as this. Awesome. Let's look at it given some different information, just to really solidify our understanding here. So we want to write the equation of a hyperbola with a center of 4, -7. A is 3 and B is 2, and we're going to assume that the transverse axis is horizontal. Okay, so we're going to say it's x minus 4 squared over something minus y minus 7 squared over something equals 1. So if it's a horizontal transverse axis, that means A is to get to the vertices. right? So a squared is going to be 9, so that's got to go under my horizontal. B squared is 4, so just like that, we've got the equation. To just add on to this a little bit, the vertices, I'm going to be going left and right 3 from the center, right? So like I can get it. 4 plus or minus 3, 7. I can get them without the graph, which means that I would have vertices at 7, 7, and 1, 7. I can also find the focus points, right? C squared is going to be equal to A squared, 9, plus B squared, 4, 13. So C would be the square root of 13, and we're going to be going left and right because it was a horizontal transverse axis. So they would be 4 plus or minus root 13, 7. I can even go as far as to get the asymptotes, right? So we're going to use the center. Y minus 7 equals plus or minus something, we'll come back to it, x minus 4. That something is going to be my change of y over my change of x. My change of y is just going to be the square root of 4. My change of x is just going to be the square root of 9. 2 thirds. 2 thirds. I don't even have the graph, and we were able to come up with that. All right. Let's look at one more. Write an equation for the hyperbola with a center at -2, 4. A is 1, B is 4, and this is going to have a vertical transverse axis. So I'm going to choose to write y first because it's vertical, and I want that to be positive. It doesn't matter as long as it's positive. I can actually do it both ways. So maybe we've got y minus 4 squared over something minus x plus 2 squared over something equals 1. Well, A is going to be the one that's under the vertical, right? Because A has to get us to the vertices. So, this is just going to be a 1. This is going to be a 16, right? That might be the equation that you have. You could really write y minus 4 squared minus x plus 2 squared over 16 equals 1. You do not by any means need to write that it's divided by 1. Or maybe you have the x first and you have negative x plus 2 squared over 16 plus y minus 4 squared equals 1, right? Like that's also fine too. These are all the same. Regardless, let's find the vertices. So we know that we're going to be going up and down because it's vertical. We're going to be going up and down 1. So I'm going to go from the center up and down 1, so that affects y. So my vertices would be -2, 5 and -2, 3. The focus points would be c squared equals a squared plus b squared, which is 17. So c would be the square root of 17. We know that it's up and down from the center, so -2, 4 plus or minus root 17. And then let's go as far as to do the asymptotes again. Right, so let's use the center. Y minus 4 equals plus or minus something, x plus 2. That something, that slope is going to be, focus on this, the square root of 1 over the square root of 16. Right? It's the change of y over the change of x. So that would be 1 over 4. And that would be the equation of your asymptotes. Awesome. So what we just did in this lesson was we used a lot of what we knew about ellipses because there was a lot of connections and similarities to help us to define, to analyze, and work with hyperbolas in a variety of forms, right? So given already having it in graphing form, having it in expanded form, giving you some characteristics, and then having you come up with the equation and other characteristics. So this was the fourth and final conic that we are learning about, that we learned about. So at this point, you know circles and ellipses, as well as parabolas and hyperbolas. So I encourage you to use some of the support resources to practice with all of them and make sure that you have some confidence with all of them. And then any questions that you have, feel free to post them, email them, ask them on Flipgrid, or ask them at office hours. Thanks for watching, guys.